Okay, hello again. Hopefully I'm going to finish the third part of this video about the football problem. But this time we're going to kick the ball not in a football field, but from a hill or a hilltop, something like this. Okay, let me go pick the draw. All right. So here's a hill. All right. And then here's you again. And here's the ball you kick. And it's going to fly and land. It can be a football or a cannonball, whatever you're throwing. That is your projectile. Here's a vertical line. And here's the horizontal line. So we define the displacement in the x direction as our range. Okay, and this hilltop has a height. If you measure it from here, let's call it h. Okay, and here you have initial velocity. Okay, I don't like the projectile, the parabolic path. Let me actually redo it. Let's find the eraser and erase this. All right. Okay, let me try to draw it again, nicer. Okay, it's better. So this velocity makes an angle theta naught with the horizontal. All right, that's our initial parameter, v naught, theta naught, and h. So the problem is find r, or let's say find the angle that maximizes the range. Okay, find the relation between r and this angle. Of course, this relation will have v naught and h in it as well. In the previous problem, there was no h. The displacement in the y direction was 0. In this case, it is not 0. So what is it? What is it? Displacement, delta y. In other words, the final position minus the initial position, right? That's not 0 now. That's not h, but it is negative h because I want to take up as positive. It's my positive direction. Therefore, delta y is negative h. Your h below your initial point where you kick the ball, all right? H is a height. H is always a positive number. Height is a positive number. Delta y can be negative or positive depending on where you end up and which direction is your positive direction, etc. And of course, delta x, that did not change, it's still r. All right, so this is my x direction, and this is the y direction. All right, so we need the equations for kinematics when the acceleration is a constant. Acceleration vector is pointing downward. This is the acceleration due to gravity. Okay, that's negative g. J hat is the unit vector. All right, so what is the equation for kinematics? Now for delta x and delta y, I have the following equations. Delta x. Okay, this will be equal to v naught cosine theta naught times t. T is the time elapsed. And delta y will be v naught sine theta naught t minus 1/2 g t squared. All right, so let's get rid of t, okay? Let's get rid of t. So I'm gonna solve the first equation for delta x for t, and then plug it in here in the second equation, right? So let's rewrite the second equation. Now delta y is negative h. Keep that in mind. Negative h will be equal to v naught sine theta times t. V naught sine theta naught times t, and t from this equation is equal to delta x over v naught cosine theta naught, but delta x is r, so I can simply write r divided by v naught cosine theta naught closed. All right, that's the first term. Now the second term. Second term is minus 1/2 g t squared, which is r divided by v naught cosine theta naught squared. All right. So let's simplify this a little. All right. Let's simplify it. Well, v naught goes away right away. So r is a constant. We have sine theta over cosine theta, which is a tangent. Yeah. Okay, so negative h is equal to r times sine theta naught over cosine theta naught minus, all right, we have r squared divided by r squared times g divided by 2 v naught squared, right? Gr squared over 2 v naught squared, 1 over cosine squared theta. Okay, so cosine theta naught to the power negative 2. All right, okay. Now what to do with it? Our goal was to find the maximum R. Okay, so I'm not going to try to solve for R, but I know R depends on theta naught. And I want to find the theta naught that maximizes R, right? So what do? I use calculus. I'm going to take the derivative dr by d theta naught. And if I equate this to 0, this is where r becomes a maximum, all right? So I'm going to take the derivative of this equation right here, for take the derivative of r with respect to theta naught, okay, and see what we get. On the left-hand side, I have a constant here, h. It's a constant, its derivative is 0. Now that equals, now I have two things here, r and then this tangent, right? So if I apply the chain rule, the derivative of the first, that's where I have dr by d theta naught. That times tangent theta, or sine theta over cosine theta naught. And then applying the chain rule, now I have plus r times the derivative of this, sine theta naught over cosine theta naught. Do you mind if I use this symbol for derivative? Just means derivative with respect to theta naught. Okay, so that's how I'm going to do it. And obviously, my condition requires that this is 0. All right? So I'm going to scratch that, okay? This is 0. So this term is 0. All right? So if I apply that logic in the second term, I will not bother taking the derivative of r again, because I know it's going to be 0, right? So let's skip that term and just write whatever is going to happen after that. So I have negative r squared g over 2 v naught squared, okay? So I'm not taking derivative of r squared for that reason. So applying the chain rule, now I need to take derivative of this. All right, let's just do it. There's a negative 2 here, which will come right there. Negative 2 times cosine theta naught to the power. Subtract 1 from negative 2, you'll have negative 3. But then you need the derivative of cosine theta naught, which is negative sine theta naught. All right, so that's what you get. All right, so let's try to simplify this a little bit. Well, first we have to take the derivative here, okay, before I forget it. So let's move on to the next second line here. Let's keep writing. 0 equals, all right, r, all right, sine theta, its derivative is cosine theta naught multiplied by the cosine in the denominator, it makes cosine squared. And then subtract sine theta naught times the derivative of cosine, that is negative sine. So this makes it positive here. Sine squared divided by cosine squared theta naught. All right, so that's 1 in the numerator, obviously. Okay, what is the second term now? We have negative, negative, negative. It's minus. Minus. The 2's go away, right? Let's get rid of 2. Okay, so I have here r squared g sine theta naught divided by, okay, v naught squared, and cosine cube. theta naught. All right, that's what we have. That's equal to 0. So why don't I get rid of one of the r's here? This cancels the r over there. Okay, and I could do the same thing about the cosine squared in the denominator, right? So from here I will get 0 equals 1 minus r g sine theta naught divided by v naught squared cosine theta naught. Okay, so okay, what am I going to do with this? Well, remember we had an equation here in the beginning, right? So why don't I solve for t in that equation? Before I do that, let me simplify, or not simplify, just rearrange the terms here. I have tangent, sine over cosine is tangent. So I have basically v naught squared over rg equals tangent theta naught. All right. So going back to the equation here, I have r equals v naught cosine theta times t, right? Now if I solve that equation, let's take this and solve it for t, I will get delta x, but I'm going to write r instead of it. R divided by v naught cosine theta naught, okay? So what am I going to do now? I'm going to replace r with what I have here. Okay, so let's move this up. Okay, so one over v naught cosine theta naught times r, which is v naught squared divided by g and tangent theta. Okay, so why don't I erase the tangent theta here? Instead, write 1 over tangent is cosine over sine, right? So why don't I just write here cosine theta naught over sine theta naught. So I get rid of one of the v naught in the numerator. Cosine theta naught cancel. So this is my t now. V naught over v naught over g sine theta. Okay. So I'm going to take this t now, all right, this t, and plug it in this equation again, all right? Plug it in this equation, I'm sorry, this one, all right? So to do that, let me move to the second page. All right, so let me go up here. Negative h is equal to v naught sine theta naught times t, which was v naught divided by g sine theta naught, all right? And minus 1/2 g v naught over g sine theta naught squared. All right, where are we going with this? Let me move this thing. You can't see it right now, but I'm just moving this thing here over there. Okay, good. I made room. Let's simplify it. Let's get rid of the sine theta naughts. It's negative h equals now v naught squared over g. And the second term, okay, there's g here. You can have g squared in the denominator, right? So the only thing left in the numerator is v naught squared. That divided by 2 g sine squared theta naught. Okay, so we're getting there. Let's factor, no, not factor. Let's leave the second term alone. Let's isolate it. So v naught squared over 2g sine squared theta naught will be equal to v naught squared over g plus h. All right. So if I multiply both sides by 2g over v naught squared, 1 over sine squared theta naught will be equal to 2g over v naught squared times v naught squared g plus 2gh over v naught squared. All right, get rid of these, get rid of g, and you have here 2 times, is it 1? Yeah, 1 plus g h divided by v naught squared. All right, that's it. That's the relation between the theta naught that maximizes r and the initial parameters h and v naught squared. Okay, so yeah, you may also find this in the form cosecant squared, right? Cosecant squared theta naught is equal to 2 times 1 plus gh over v naught squared. Okay, so will it be 45 degrees? No. It's going to be a different angle. Maybe 43, maybe 41, depending on what your h is, all right? But that's the answer to the part B of our problem. Let me stop the recording now. By the way, the music in the background is Thy Catafalque, a one-man band called Thy Catafalque. Check it out. Okay, bye.